So we will start with today's session. Give me a minute. I'm just in case I get out of the network, so I make some people co-host. All right. So okay. So day one, you start with a very good overview of what are blockchains. Professor Sandeep Shukla covered all the aspects of the current blockchain technology, and then Professor Amey Karkare gave you an idea of how to make smart contracts, what is solidity language, and how we can effectively use solidity to build smart contracts which are useful. And he also told you that smart contracts are important. May I request all of you to please stop your videos because when we see that people are moving around, so it distracts the speaker. Thank you so very much for your cooperation. Um, and okay, fine. So I'm going to share my screen. Please let me know if you are able to see the screen. Just give me a minute. All right.
Recording in progress.
Are you
Recording stopped.
these topics interesting? Tell me yes. This is an altogether new technology.
Recording in progress.
Right. So everybody takes a little time to understand the technology. So don't worry if you are not able to get it. Now, today we shall be discussing about blockchain-based applications, which are purely decentralized applications. You can see this big picture where blockchain applications can range to, say, healthcare, to insurance, privacy and security, identity management, data management, fintech companies are using them, and then integrity verification. In governance, they are very much useful in Internet of Things. So fortunately, what has happened that blockchain technology, Internet of Things, cyber physical systems, and the new generation of AI, they are all emerging together to make the lives of people easy, to solve some very difficult problems, right? So if I call it a disruptive technology, it is, I think, is the right thing to say that it is a disruptive technology with applications in various domains: fintech, healthcare, governance, as I told you, all these, and there is a long list of application domains. Think of any domain, and you can have applications which require decentralization. The moment we say decentralization, blockchain is a wonderful solution for this participant. So, if I look at these areas, blockchain, this research and markets is one of the most important companies that does market analysis and research, and basically market research analytics company. So what happens that if I look at US, the current trend, last year trend, it was around 4.9 billion as it found out. But if I look at 2026 forecast, it's going to be 67.4 billion, which is quite high as compared to any other technology that is reshaping the world. So if we look at the top 5 technology blockchain growth trends in 2021, it's a Capgemini report uh, published in 2021. It says that there are 5 areas where blockchain can make a lot of impact. So blockchain for AI, blockchain for countering frauds, and many more things. So the question is why blockchain is growing so rapidly. Professor Shukla and Professor Amey Karkare have already told you that this provides a trust mechanism. So what about it? It's basically providing trust mechanism in a trustless environment. You may not be knowing with whom you are doing business. He can be just your next door neighbor, or he can be somewhere sitting on the other part of the globe. So it's basically providing you trust mechanism to secure real-time data sharing in a decentralized peer-to-peer network, right? So one thing very important, trust in a trustless environment. And because there are no intermediaries, this is a totally decentralized application and development. So what happens that the speed of transaction is expected, I'll come to that a little later. Reduced cost is there. Why? Because there are many manual tasks which could be automatically done through the smart contracts. So think about those who are living in the government system. They may be knowing that take for example audit process. For audit process, first of all, those accounts and ledgers are checked by internal auditors. Then there is somebody who comes from the state level. They do manual checking. It's a huge volume of files. So they cannot check each and every file. They have to do random checking. And from random checking files, they find out if there can be an anomalies, there can be some irregularities. So it's not a complete check. And then that the audit process, the final authorities come from the central government. So that's how it happens. It takes a long process. Every quarterly they have to visit us. Even then, they visit us quarterly. There will be so many files which will remain unattended. So because because everything will be governed by smart contract, it will be automatically executed. Anything there is an anomaly will be automatically detected. So it makes things very easy. Ensures immutability, as you know that if I have a block, it's block header, right? I'm putting my video off because it shows that my internet connection is going a little unstable. So it ensures immutability because the current block header has connection with the previous block header. So any transaction that has taken place in the current block and is recorded in the current block will have roots in the previous blocks, and therefore it is not possible to temper or to erase any record, right? So then the data access control, you can decide who can who can view your data, who can access your data in the read-write mode. So it is all depending upon your priorities. You can definitely decide. So every single user is the full authority of deciding what to be done, what not to be done for the given data. And then it converts assets into digital tokens. You have helicopter, you have a small piece of land, you have books, you have clothes. They all can be converted to some kind of digital tokens. with their ownership cannot be compromised because the digital tokens will have encryptions that will be having links with your own address. So they cannot be compromised like non-fungible tokens, right? So non-fungible tokens, if you are not aware, it just serves the web. You'll find that this is one of the most important and growing business in the world, non-fungible tokens. Say, for example, take a piece of art that you have created. You have created a painting and you post it on your Facebook. That will be immediately stored. If that is stored, that will be immediately stolen and somebody can claim that it is his work. So if it was in a network which is a decentralized blockchain network, this stealing of the copyright material is not possible. So there can be many things which can be converted to non-fungible. So ownership of non-fungible tokens remains is a unique ownership. So it cannot be like it is not possible to tamper with the ownership of the non-fungible tokens. Then we have better collaborative platforms to solve some seemingly intractable problems. Like we know that there are 17 sustainable development goals for the entire world, in which zero hunger, no poverty, climate change. These are very important problems, prevalent problems for a long time now. Blockchain has started. People have started to think about solutions using blockchain. And if you see one of the very first books in which it was during the Syrian war. You know that Syria has been struggling with the internal wars and all those things. So how those Syrian people who were in different camps could be provided food with no duplicates. Like it should not happen that I am taking again and again the food packet and my neighbor is not able to. So this and through a method which is quite like blockchain-like. So blockchain, coming to back to the blockchain decentralized application, which is the topic of today's discussion. If you look at the blockchain application, which is decentralized basically, is designed and developed as we call it a D app. Now, what is a D app? It provides an environment for peer-to-peer interaction between people, between applications, between two systems, like two systems. One can be a diagnostic system for medical for patients, and the other could be the kind of system between two systems which may not be known to each other. So this is something important, that the person one, person two have no connection. They are not known to each other. And so it is an end-to-end application on a blockchain network, and it depends on the functionality of blockchain. Functionality of blockchain is completely decentralization, right? And functionality of blockchain depends on where you define the business logic, the smart contracts, right? But to make it very simple, what has happened that the client application is the normal web application kind. So it can be a web app, it can be HTML. And please let me know if you are not able to hear me, right? Just in case you are not able to hear, please let me know. Garima Sinha wrote that your voice is breaking. Lag in video audio, how is it? Your voice is breaking a lot. Some people are saying, please let me know. Voice is breaking. So please wait for a while. Please wait for a while. I'll transfer to another system. Thank you. Thank you all of you for giving me the feedback. I'm coming back to the difference. Can you hear me? Thank you so very much. I'll again try to give you a brief idea of what I did discuss. I discussed important things about blockchain decentralized application. The moment we say it is a blockchain application, basically it is decentralized. There are various areas, domains where blockchain has penetrated, and one of the very important ideas that is emerging is the concept of non-fungible tokens. Right, so non-fungible tokens are what kind of tokens? Thank you. So non-fungible tokens are like anything that you own. You can put it in a blockchain network and in the form of a digital token. So starting from land to helicopters to your piece of poem, artwork, these are all, they can be converted to digital tokens, which are non-fungible token with unique ownership. I was telling that the back end of a blockchain application or a decentralized application, which is known as DApp in short, its functionality depends on the blockchain, and therefore, when we say functionality depends on blockchain, means what? You have to think of and design properly the smart contracts which define the functionality and also take care of non-functional aspects of an application. But the front end remains like that of a web app. It can be HTML or JavaScript framework, anything like command line interface, desktop application, or mobile application, anything of that sort. All right, so the front end will, of a decentralized application will represent what is the user is, user wants to see, what user sees. And the back end represents the entire business logic, right? So for defining business logic, several smart contracts may be required. You may be thinking that I will make a full like main program and I will be calling different functions, different programs within the main program. Well, I again would like to say that keep your smart contracts as simple as possible, and you can call functions in the from the present contract to another contract. You can call functions, but the logic should be simple, right? So you can break it into pieces like in modular programming we do. The same way you can do here. But it has to be a contract-oriented program. So the front end as well as the documents, files, like photo, video, audio, can be hosted on decentralized storage network, like interplanetary file system, Swarm, CR. These are some of the important file systems which are there, which are decentralized storage. Somebody was asking yesterday, is it a distributed system? It's not only distributed, my dear friends, it is completely decentralized. Distributed can be partly or can be fully centralized. The processing is distributed. Processing of things are distributed, or storage is distributed. Still, it can be centralized. So if I look at the D app, the D app is having essentials of D app. One has to have smart contracts. So from where you will be accessing those smart contracts, that has to be this client. So there is a client application. For what application? For example, it can be healthcare or insurance or claims for insurance claims. All these can be examples, client applications. The client applications will be through some API, they will be requiring smart contracts to execute some logic, right? And then for storage, we have storage or decentralized storage. For making this happen, you have to have a network and a computing platform. So blockchain network, each node of the network or some specific node in the network, which are full nodes, provide you the computing platform, right? If I look at the Ethereum based DApp stack, starting from the hardware which requires computing, you have on the top of this hardware peer-to-peer network and operating system which deals with this. Then you have an Ethereum virtual machine, just like we have, the concept of virtual machines. So virtual machines will have their resources somewhere. So in this case, in the peer-to-peer network, we have in the network, there are some nodes which are known as full nodes. Those full nodes will provide you their resources for doing computing and for storage. And then we have this application framework, which will define what is the business logic of the application that will be executed through smart contracts. And then you have the final end user application, right? So please feel free in asking questions. Now, Ashutosh, you were asking how storage is different from blockchain networks. The network is a network, and storage is you have a computer network and you have a storage in each computer, right? So decentralized storage, unlike a centralized storage, is owned by, that the centralized storages are owned by single companies. Like if I say Google Cloud, or you have various cloud servers which provide you storage services. So here decentralized storage consists of users' storage who are in the network and who hold a portion of the overall data. They hold it in such a way that it makes it resilient file storage system. So in any case, there is no possibility of attack, and there is always availability of the data. How this is possible? Give me a minute to explain you. So these storage systems, they share storage responsibilities among independent operators. They will form suppose you have 10 people in a network. Those 10 people, out of those 10 people, 6 decide to share their resources, right? So they will be having the responsibility of making data available for all times to come, right? So a storage can be a blockchain-based or any peer-to-peer network-based storage system. Now you must be thinking blockchain-based. Blockchain means on the chain. It can be on the chain, or it can be off the chain. Like I'm a member in the network, but I have kept my storage off the chain. That is also possible. But why storage? First of all, it provides a single source of data, truth for data, right? So whatever is the current state of data, to think about a database system where there is a dynamic entry. Dynamically, it's a dynamic, right? Today somebody is entering, like for example, let us take today's session. In this session today, I see that there are 581 people, and someone may lose connections, they may get out, and some other people may get in. So it's a completely dynamic system of registry and going out. Now, at any point of time, only I am able to know that how many of you are present, who exactly are present. Think of a system where each one of you had a copy of this information that these many are currently present, right? So here through participants list, you can see that. But that is only because we are able to provide you that service. We means the central storage system is able to provide. What if the central storage system is off, it will not be able to provide you all the information, right? So it is fault tolerant. Availability, it provides availability, assures availability, scalability, which is very important, and performance. So if I'm a member of Google Storage, Google Drive. So tomorrow I have been provided, suppose 15 GB of free data, right? Beyond 15 GB, I will be definitely charged. And so scalability of this will depend upon how efficient any storage system is. If they are not able to scale up, their scalability will be affected. There are various things about scalability and about basically decentralized storage. Now, coming back to Ethereum blockchain, this also works as a decentralized storage system. Some people are asking questions. From time to time, I will answer your questions. Please wait for a while. So Ethereum blockchains also works as a decentralized storage system for smart contracts, because the smart contracts have to be on the chain, right? But if I look at the blockchain, sorry. I'm so sorry. If I look at the blockchain growth, can you see my screen? Okay. So if I look at the blockchain growth, I would like to show you how Ethereum blockchain is growing. See, if I full node sync default chart that is showing from, say, sometime, it says July 12, 2019. So if I move this, you can see how the data is growing. It's a get default on which, if you can see, this is get default, and the other open Ethereum default. So you can see the amount of data that is growing, and you can see that this growth is exponential, right? Now, if we use Ethereum blockchain as the storage, it's going to be very difficult. Every node on the blockchain network should hold all the data, which is too much to demand. And if the chain grows as per the prediction, well, it will not be feasible to run the chain, right? So, and secondly, the cost of storing data on the chain will be so high that it will be difficult for people to maintain that. There are gas charges. Now, I will come to gas charges in my next lecture. Don't worry what is meant by gas, but gas is something like a fuel, right? It's a fuel. So whenever you cook, say, tea or coffee, you need some gas, right? So that gas charge will depend upon the price of gas that day, right? But the amount of gas will be the same. If you are making 2 cups of coffee, the amount of gas will be almost the same. But the charge today and charge 2 years earlier will be different, right? So on the other hand, if the unused storage, if we take the unused storage space of all the users, the average users, it is said that the whole centralized cloud computing industry, think of any like Amazon, Google, think of all those big giant companies which are providing you centralized cloud services. It is only a small fraction of users' collective storage space. And therefore, if we look at the D storage, it can offer people with more storage than anything else. And that too at a very cost-effective manner, in a very cost-effective manner. Now many of you must be thinking these distributed and decentralized. Distributed and decentralized. So if I look at the centralized databases like SQL, many of you must have worked on these types of IBM DB2, Oracle, then MySQL. Then we have distributed databases. We have distributed databases. These distributed databases like NewSQL, NoSQL, then there are two types. One is purely transactional and the other ones are analytics based like Hadoop. Then we have, so these are all managed by logic. They're basically centralized systems, these are. Now, if I look at the decentralized system, these are distributed ledgers, as I told you. They are on the network of, they are with the users in the network. So they are cryptographically enabled, decentralized distributed databases. And so like Bitcoin, Ethereum, there are so many such databases which are completely decentralized and distributed. So I hope you understand that distributed means it can be distributed, but the management is centralized. It is not decentralized, right? Thank you. Now, whenever we talk about decentralized, everybody who is in the network, how do we ensure that somebody, like you just saw that my voice was breaking, so my network was unstable. Now, how to design an efficient persistence mechanism? And whenever I am, say, asking somebody to keep always, remain always online, how do we reward them? What kind of incentives do we provide? So this, sometimes they can be like blockchain based, as you know, that blockchains are always, all the blocks are always available. They are on the main chain. They are each copy, each user, each full node is having a copy of that ledger, right? So like Ethereum, Arvi, these are examples. On the chain, keeping data is very expensive, so it's not a very good solution. They can be contract based on certain contracts. These Filecoin, Skynet, Ojha, these are examples, right? And then are distributed systems with contract-based incentives. So distributed systems are distributed, but then we have certain incentives which are given to keepers of the data. Right? Now, whenever we say that this decentralized storage is there, data retention is an important issue. So what happens that storage nodes are constantly audited. How do I know that the person is having the current state of the data? So they are audited from time to time. And that is also done through smart contracts, right? So they are storing the data. How do we know that they are storing the data? So that requires, say, cryptographic challenge mechanism, like in Arweave proof of access. So they find out the current data, current state of the data, and then they randomly consider any former data. I mean, it can be any other block data that was previous data block. So there's some challenge mechanism that is thrown, and everybody has to pass that challenge, has to accept and pass through that challenge, right? Then there are incentives for storage nodes. And through this, malicious behavior can be easily detected, very easily detected. The moment you put audit process, so somebody is being rewarded for keeping data and he's not keeping data. He is utilizing the storage for some other purpose. How do we, penalize such people? So for them, Because this cryptographic challenge mechanism is very foolproof, so malicious behavior can be easily detected, right? And then redundancy is to be maintained, although that requires a lot of data, additional data, but for keeping data for all times to come, it is important that there should be redundancy. There's some question, how would one find the latest and data, greatest data for audit in decentralized storage? How would one find the latest and greatest data? Well, uh, everybody keeps a record of all the resources that are free, right? Like I will declare that I have got 50 GB data resource available. The moment new data comes, people are having a copy of this. Suppose there are 6 full nodes. All these full nodes are having a copy of this data. So everybody knows that I have got 50 GB. Out of this, 6 GB is already exhausted, right? 6 GB is exhausted, number one. The current data, that is the full data, is having a hash value. That hash value is there on the main chain. So just like a pointer, which is pointing to the full data, there this hash value only is stored on the blockchain network, right? So everybody can access through that hash value. Who is given the access right can access that part of the data. So these full nodes, which are responsible for keeping data, among them, there is a consensus that people will be throwing, and that consensus is also executed through smart contracts. It cannot be tempered. So they will be throwing challenges, this cryptographic challenge, and by throwing those challenges, the results will be known to everybody that these many full nodes are having this much of data. That is the current state of data. I hope I have made my point clear. Is that clear? So basically, it's a pointer. It's a kind of cryptographic hash that is there. Somebody has written, pardon me, I'm so sorry, I didn't notice anything that you did, but I expect all of you to remain online, because here there's no method of checking who is online and who is not online. It's a consensus. I think we'll be discussing this a little later, but Professor Sandeep Shukla has already given you a very good introduction to consensus mechanism, the proof of work, the proof of stake. Now, how to become a node in the blockchain? Very good question. You have to join that chain, and remember that whenever you become a node in the blockchain, it can be a node for just verification of something or for doing some transaction. So whenever you wish to become a node, you will have to have some wallet, some tokens in your wallet, right? More about this you will learn in the next lectures by Professor Amey Karkare and Samir Jain, because they will be talking about, perhaps one of them will be talking about wallet software. So you have to have a wallet. In case of public blockchain networks, in case of private or permission blockchain networks, the mechanism is a little different, right? So we will come to that point a little later. How to become a node for becoming a node which is a full-fledged node, like full node, you have to have huge computing resource, right? And huge storage resource as well. Now, so remember that I have been talking about IPFS, Interplanetary File System. If time permits, Samir will also take you to this Interplanetary File System. But I wish to give you a glimpse of this. I hope you are able to see this. IPFS powers the distributed web. Peer-to-peer hypermedia protocol designed to preserve and grow humanity's knowledge by making the web upgradable, resilient, and more open. So here you can see how to get started, how does it work. Here you can see it's very beautifully written here that the web of tomorrow needs IPFS today. Like today's web is inefficient and expensive. Today's web can't preserve humanity's history. Today's web is centralized. You can go through this and how to install IPFS. This is something very simple to do. If time permits, we will be covering this in the lab session, right? So it's this is open source. All these for blockchain technology, one thing which is decided through consensus is that these have to be all open source, right? So this is an open source. I come back to my slide. So important point is when you store data on the storage, basically what happens, storage means there are suppose 6-7 nodes which are having the responsibility of keeping all the data and its current format, previous format, everything. Remember that if you have say for example file system, you keep all the versions of a file, right? When we do say word processing or any other processing, the moment you edit it and save the next version, the previous version is after some time you can find out some previous versions, but it is automatically deleted. Here it is not like this. Here every version will be saved separately. That is important in this storage, right? So it is fragment because as I told you, nothing can be tempered. It's a record, right? So when it is a record, where, for example, think about your grade sheet if you are a student, or if you are a teacher, you are giving grades to somebody. Now what happens that in the first semester, suppose somebody gets an F grade, fail grade, and he reattempts the same course and he reappears in the same course, reattempts, and he gets suppose a B grade. So never in the records of an academic institution, F grade will always be there, and the reattempt, after the reattempt, grade B has been awarded. So this is a ledger. Like a ledger, nothing can be deleted. It can be appended, right? So now I'll come back to this. So any access request leads to fetching different fragments from those multiple locations. So what happens that suppose you have given data for storage. It is a file. That file will be fragmented into 25 pieces. Now those 25 pieces, again through a cryptographic process, they will be encrypted and they will be kept in suppose some 80-90 locations, right? That is how it happens. So there's no single point of failure here. Somebody is asking, I'm sorry, your name is not there, how to start a blockchain. Wait for a while. We will show you in the next evening session. You will be able to create your own blockchain, but that will be a private blockchain. because these are test blockchains. The moment you go to a live blockchain, you will be charged money for public blockchains that are available, that we are going to show you. So we will show you how to create, how to start a blockchain. Somebody is asking, he must be a student, or I believe, or she must be a student. So let us think of creating a blockchain among all the learners in this network. So that blockchain will require some kind of a maintenance of blocks, right? And therefore, some kind of money is involved. Some sort of tokens are involved. So that token can be in the form of rewards, can be in any other form, right? So that is why you need to have, what we will do, we will see how test blockchains are created. Test blockchains are, you can do any number of transactions on those blockchains without spending money. So we will show you how to create a test blockchain. Yeah. So then, so if I look at the traditional web app and the decentralized app, you can see here that the data center, in case of a web app, is centralized, right? Data computing, these are all like main computing, where your backend support is there, right? So they will be all centralized. Whereas in case of the app, it is the common resources which are available in the network are used. I have been talking about decentralized app. Let's take a look at how decentralized app differ from traditional web apps, right? So traditional web apps use HTML, CSS, JavaScript, etc. to render a web page. And this page directs to a centralized database. Now think of any application. You use Amazon, you use Twitter, Facebook, Flipkart. These are very popularly used services or applications that we have been using. So they are all using some API. That API will be dealing with the backend to display data, to do the service that you require. So they all depend on some user ID and password. Like you must have heard about recent Facebook hacks, right? So ID and passwords are hacked. Sometimes we also come across some such situation that my password is hacked. So your personal information is stored on the servers of the service provider, which is basically a low level of security, because everything you have to depend on that central server. If that is hacked, that is compromised, all your data, personal information is compromised, right? You agree with that? I see some questions here. So API means application programming interface. Whatever application you are dealing with, that can be, say, an insurance or Amazon. Think of Amazon. You're buying some goods, you're buying some items. So that how this request will be processed. This request will be processed by accessing some data and doing some operations. So who will be responsible for doing this, right? So what happens that you get, you want to, for example, think of a messaging, think of a postal service. The postal service is you're writing letter, you want to send it to somebody, and that somebody is sitting somewhere in Coimbatore, and you are sitting, say, in Patna. How is it possible? There's somebody who is doing some job on your behalf. And there are post offices or drop boxes which can be, for example, an application programming interface working like that, right? So this is kind of an API. So You are simply putting this on that post box, and then somebody on the other hand is doing the back end work. So front end of a D app uses the same technology to render the page. But remember that the front end here, in this case of blockchain technology, thank you, Preeti. But the front end contains a wallet that communicates with the blockchain. Remember that the wallet manages cryptographic keys and the blockchain address, right? And the public key infrastructure here is a cryptographic protocols that we use. They use the public key cryptography for user identification and authentication. Those who are not aware with cryptographic systems, Professor Sandeep Shukla has given you some idea, but we will be dealing with more cryptographic protocols and blockchain security. Later, Professor Sushmita Ruj from New South Wales and Dr. Emmanuel Pilli from MNIT Jaipur will be telling you more on security aspects of blockchain. So please have a little patience. We'll be covering that part also. Now remember here, instead of an API connecting to a database, the wallet software is used to activate smart contracts. That is the difference here, right? That's the difference. All right, which in their turn interact with the blockchain, right? So if I look at this, in essence, we can say that the traditional website is front end, which is dealing, which is calling an API, which in its turn calls database. Whereas in Web3 compatible website, it is front end, including wallet, which in its turn calls a smart contract. Smart contract calls, I mean, definitely these are there on the blockchain. Through the blockchain only, blockchain provides you the computing platform that also provides you with these smart contracts together with the blockchain will help you access the D storage as well. So Web3, I'm talking about Web3 now. Some people confuse with the Web2 version, Web3 version, something to do with the network infrastructure or the network capabilities, communication infrastructure. No, it's something different. The idea here is it's a World Wide Web that incorporates decentralization, right? And that decentralization is based on blockchain. So it's like an internet owned by builders, like software builders and users, and it is orchestrated with tokens, remember. So backend always of a decentralized, I'm repeating because there are some things which we need to repeat again and again. Remember that DApp in Web3 consists of what? Smart contracts. Smart contracts, so if you are able to design properly smart contracts, you are able to test them, develop them, you have defined properly the business logic, right? And then deploy them onto the decentralized peer-to-peer network. This term was coined by Gavin Wood, who is one of the co-founder of Ethereum. And this gained popularity. Why? In this last year only, it gained huge popularity. Why? Because cryptocurrencies, people started thinking about using cryptocurrencies. And internet of, and there are so many tech companies, manufacturing companies, governments, financial institutions, they are also finding this technology to be quite useful. So just like people say that it is like a revolution, it's going to create a revolution like the revolution when electricity was started. Electricity was started, I mean, people started using electricity as a common commodity, it's a useful commodity, right? Can we say, the question is by Amit Kumar, can we say smart contracts provide similar functionalities like an API? API, basically, it's only connection between one and two, right? It's the back end and the front end, right? Smart contracts, on the other hand, will define the complete logic that you want to do for your business. For example, if it is claim related to insurance for a medical healthcare service, then all claims, how those claims will be addressed, how we will ensure that if a person has claimed for X amount of rupees, he is eligible for Y amount of rupees, and so on and so forth. So all these things will be done by smart contract. So it is like revolution when electricity was started as a commodity for common people, or you can see that internet. People say that like the internet. When in 90s, early 90s, I remember when I used to write a mail to my friend or to my colleague, we had to wait for a full day so that it goes to a central server from where it is delivered. Now internet has become such a common commodity that people never think that internet could be anything that was a very rare commodity 30 years ago. So I have been talking about wallet software, my friends, but I have not spoken about wallet software. What is a wallet software? Wallet software provides a unique encrypted identity. That encrypted identity is bound to the resource that a user is using. For example, my mobile, my desktop, that will be my resource, right? So all the transactions are cryptographically secure, and no one in the network will be able to change any transaction made by user. On the right, you see a wallet software. It is one of the most popular wallet software known as MetaMask, and we'll be discussing about it in next sessions. Okay. Let us have a small mental break. What is V? V is the smallest denomination of Ether, a cryptocurrency, which is used in Ethereum network. So 1 Ether is equal to 10 to the power 18 V, right? So when you will be using remix environment in Ethereum blockchain network, you will find on the left, there was a column on the left where from Professor Amey Karkare was fetching those accounts, and some gas limit was also specified. There you may probably find V's also, the V. And what is Satoshi? You know that Satoshi Nakamoto is a pseudonymous person or a group of persons who have introduced the concept of blockchain for currency exchange, cryptocurrency exchange. So Satoshi, to honor the person, Satoshi is the smallest unit of Bitcoin blockchain. So 1 Bitcoin is these many Satoshis. Find out how many. And what is the current value of 1 Bitcoin today? My dear participants, in 2018, when I was thinking to introduce a new course in my institute for undergraduate students, I thought, let me study blockchain and then let me introduce this. So in the summer vacation, I studied blockchain using Coursera and quite a few wonderful books on blockchain. And then in the next semester, coming semester, I started teaching the course. And that time, the blockchain technology, this 1 Bitcoin was somewhere around, I think, 7-8 lakhs or something. Now it is, you can see it's so much of amount, it's 39 lakhs, right? So you can see in what is the growth. account around $65,000. You're good at converting to dollars. I'm happy because when it comes to money, conversion is something very difficult for me. Right. So coming back to this, design methodologies. Design methodologies for the apps are like the process is exactly the same. First, we do analysis, just like any software development. We identify entities, we identify their roles, interaction between entities. Somebody wrote that when I invested in Bitcoin, it was 5 lakh. Great. You have become a multimillionaire. That's very nice. So example can be, suppose you are defining an auction process. Beneficiary who announced this auction, bidders, an auction, all these could be entities. Then first you analyze, like you also do requirement specification for any software, right? Then you design model entities, list all the attributes that that are there, right? What will be the interactions? Then you start developing smart contracts, implementing, and then you also design the front end, right? Then what do? Something very important to do is don't forget to test smart contracts very thoroughly. It has to be very comprehensive because once you put smart contracts on live network, it is just like a live transformer in an electric network. You cannot touch it, and anything that goes wrong with the transformer, the whole system will be gone. Right? So that is something which is very important. Blockchain is distributed database. How does it differ from traditional database? That is what we are trying to explain to you, Sumit. It's a traditional database they can be distributed, but here it is completely decentralized. It's a completely decentralized in the sense that no one is having the ownership. No single person. Every single person is having ownership, and no single person can claim the complete ownership. Now, another question by Vinayak, in a blockchain, all the nodes have the same block of data. So whenever one node adds data in one block, can other nodes add in the same block if space is available? No. So space is made available through the storage, right, for large data. For small data, like hash or something, which is stored on the blockchain, every single change that happens in the data of the network, that is stored on every full node. Why can't we use Bitcoin as the real money to buy anything in India? Well, I'm not authorized or the person to tell you why we can't do it. So the cryptocurrency has to be, we will see there are various challenges with the cryptocurrencies. Like right now, in these public networks where anybody can enter, anybody can go out of the network, regulatory authorities, how do we regulate these? How do we ensure that there is proper mechanism to have inappropriate, one should not be having any kind of, say, tax saving. I'm gaining income, but I'm not paying to the government. That is also something which is important. And if suppose something goes wrong with the network, we talked about 51% attack, right? Then who is responsible for 51% attack? The third thing, that it may happen that my smart contract is not properly written. It's not, there's some bug in this. Due to some bug, it can happen that somebody is able to gain access to a large amount of ether. How do we ensure that this is not happening? So sometimes, you forget your credit card somewhere or your debit card somewhere, then immediately report to the bank. Bank immediately seizes that card, right? Operations on that card. It is not possible in this case. So all these regulatory authorities are are able to do it. Right now with the public blockchain, this is not possible. But definitely with private and other blockchain that we will discuss in the next lecture, we will see how this is possible. There are so many questions that are coming up. Let me answer those questions first. So one question is distributed database. I've already answered. Then testing a smart contracts means, so somebody is asking how do we test? See, there are black box tests, right? You give the input and expected output based on the logic of the smart contract, right? The expected output, if that differs, then you have found out there is some bug. That is what is testing. And then there is some white box testing. You go through the code, you do the code coverage, entire code coverage is done. So you go through all the steps, all the branches in the code, and you check whether those are properly giving the outputs, those are properly defining the logic. So that is what is there. We can say traditional database can be distributed, but it cannot be decentralized. Yes, DApps are distributed as well as decentralized. Very good, thank you. What do we mean by bidders in the auction process? Like bidders, Harsh, auction, what does happen in auction? Auction में क्या होता है कि हम किसी को कुछ सपोज अभी आजकल बैंक्स जो हैं लोन लोग ले लेते हैं और वो लोन पटा नहीं पाते हैं, तो बैंक्स जो है वो ऑक्शन करते हैं. उस केस में बेनिफिशियरीज बैंक्स होते हैं क्योंकि उनको अपना पैसा वापस लेना रहता है लोन का, राइट? नाउ सो दे अनाउंस एन ऑक्शन प्रोसेस. When they announce an auction process, that means they show the intention to sell the property, right? That selling of the property is properly announced. So many bidders will be there. I will be saying that, okay, I am able to take it in say 25 lakhs. Another bidder will say I am able to take it in 26 lakhs and so on and so forth. That is what is known as bidder. How Bitcoin is used in transaction? Bitcoin is used in transaction. Bitcoin, for transaction you need some computing, right? For transaction you need some computing. Who will be rewarded for, like, if suppose you are using my resources for computation on a blockchain network, I must be paid. When I am paid, it depends on the amount of computation you have done on my computer, right? So then the cryptocurrency is used. So that is why blockchain and bitcoins are used for transaction. Can creator of a blockchain add blocks in that blockchain without consensus? No, not at all. No creator can add a block without consensus because it's a completely permissionless, right? So what I mean to say that everybody has equal role. So if there is only one person in the network, then he can definitely create. The moment it becomes two, it has to be consensus. If the government is involved, somebody is asking, if the government is involved, how come blockchain will be decentralized after? Yes, I'm Vinay. Very good question, Vinay. We will be talking about different types of blockchains in the next lecture, right? So I will show you how governments or enterprise level blockchain works. What is the, and in the next course of lectures, you will study more on Hyperledger Fabric, where we will be also looking at how enterprise level blockchain can be created and work. And so there will be some semi-centralized kind of, and that too by consensus. Okay. Bidders in auction process. Sorry, I don't know if I missed. Sorry to bother with same question. No, nothing is a stupid question here. Nothing is stupid. Like what happens in 50-50 case? And so theoretically, yes. Practically, infeasible. Theoretically, those things which can be done, practically these are infeasible. How the details of transaction is maintained in blockchain? Yesterday, Professor Shukla told you. So, if time permits, I will tell you. But Professor Shukla told you that suppose I have got 5 rupees in my pocket. From where these 5 rupees have come? 2 rupees Samir gave me. 3 rupees Professor Ame gave me. Right? Now, from where they got those 2 rupees and 3 rupees? So Samir got 1 rupee, say, from Purnima and 1 rupee from Nishant. So then everything will be traced back. So this tracing back. So I got 2 rupees. I just tell that this 2 rupees I have got from Samir, and this from this 2 rupee, 1 rupee I am giving to say X person. Now, so it will be traced whether I have already exhausted 2 rupees before in a transaction or not. Because I am claiming that I have got 5 rupees, I must show the proof that I must have the proof that these 2 rupees are still existing. There's no double spending. I am not claiming like I am not paying to Amazon and Flipkart at the same time and taking 2 different commodities. And so only the central server, that is bank, will be able to deny. Whichever comes first, they will be paying to that. So here, it is through the blockchain everything is maintained. Okay. When somebody is asking, when mining comes in picture to define a consensus, right? To have a consensus for creation of block, right? So for creation of block, we will be coming to that topic a little later. Authentic real physical thing is not again sold. That is the beauty of blockchain, my dear Ashutosh. How do you see that this is not sold? The moment it is that there is a transaction between 2 peers, that I am selling you my pair of shoes, then that message is publicly like broadcast in the network, and therefore the ownership change is publicly announced, right? No, same image in different format. That is the beauty. Like the moment you access an image, it will have an address. And that address will be having an encryption. That encryption will be containing all the details of who the owner is. So it is not possible to have a copy of the same file, right? Yeah, MD5 hash will be different. Yes. Somebody is asking MD5 hash will be different. Yes, it is different. We'll be talking about more on security a little later in one of the future days. Distributed digital ledger is used for recording transactions in blockchain. What does the system rely on? We have been talking about consensus mechanism. Sumit, the consensus mechanism makes everything reliable, right? You hadn't explained my question, which I asked from you. What is the question? I don't know, Priyanka. Will you please repeat, because this is a long list, so many new messages. So I come back to the without Bitcoin mining, how Bitcoin transfer. How gas fee and mining. I want to listen to your lecture. Please take questions at the end. Ajitji, thank you for telling me, but then there are so many young people who have got a lot of curiosity about Amar is asking, suppose I gave you 1 rupee and Samir sir gave you 1 rupee. No, the hash of both will be different. How Priyanka is asking how DFs are important for the functioning in blockchain technology, because decentralized applications, see, why are you using blockchain as a backbone infrastructure? You want to utilize its functioning. You have some application. That application can be, say, agriculture application or healthcare application. Agriculture application, think about an agriculture application where so many farmers are struggling to find out solution to some pest control or disease control problem, right? And there is a network of farmers and experts. So what will happen, that farmers will be sending request by putting their images on the network that this is the kind of disease I am finding. Experts will be immediately telling the solution, and the expert who gives a reliable solution is rewarded. That can be this. So how to use blockchain for forensics? Is there any open tools available, Sakshi? We'll come to that in the on the fourth day, perhaps. I go ahead. So let us take a simple example of having auction process. So there is a beneficiary who creates and announces auction, like banks, and they reveal winner. That means whosoever gives the highest price, bids the highest price, will be the owner, right? So auction for fundraising, registers and bids in the process. So we will list all the state variables for each of the three entities, like beneficiary, auction, and bidders. These are three entities. We list all the functions, their parameters for each of the activity, like reveal winner, register, and bid, right? And then during development, you will be making all these different smart contracts will have their own state variables, like public. It's a beneficiary is a variable, bidder is a variable, what kind of items it could be there. Similarly, functions could be many functions, like auction, register as a bidder, right? Bid. Once you are registered as a bidder, you can bid. And then there is another function, reveal winner. There can be many functions, right? Then we implement smart contract in high level language. Can be Solidity, can be Python, can be Java, anything Ruby. And then we compile the contract to get the contract binary. We test and deploy the contracts on a blockchain network. And then we build a web app that interacts with this. So there are plenty of open source DApp development framework, like Truffle. You will have an experience on Truffle today, and then Hyperledger Fabric, we'll have experience on Hyperledger Fabric later, right? Well, Samir will tell you more on how to install Truffle, and it's very simple. It's very simple, believe me. And then how development of DApp is done using Truffle. So first of all, we create a directory, right? So initialize a new project using Truffle in it. The moment you write Truffle in it, it initializes the project, and then it creates all the required directories. And then, so that will be some source code, migration directories, some various types of directories it will be creating. Then Truffle compile. It will create the contracts. So first of all, we need to create all contracts, and we put in the contract directory. So this create a directory will create the contract directory, the migration directory, many other JSON objects. All those things will be created by Truffle. So Truffle is a tool which helps you, which makes your life easy in creating an application for blockchain, and it helps you. You will be able to create accounts that can run on a blockchain network. We will see how that happens. Then Truffle compile will be compiling all the contracts. So before you run this command, you have to put all your contracts in this contract directory. Then we generate the test blockchain account using truffle develop. As soon as you write truffle develop, you compile your contracts and you write truffle develop. It's a single on command line interface which truffle uses here. So suppose I write truffle develop, it will generate the test blockchain. I told you that test blockchain, you can do any number of transactions without costing you anything, right? And then deploy the compile contract by making use of truffle migrate. So it deploys on your smart your application on the blockchain network, and then we test the DApp, right? By adding and testing code. You have to create your test code, right? So it will give you a test directory also, where your test code will be available, but then test code will be very skeletal kind of code. You will have to add the test sequence in that, right? So this all is a full sequence. So once you test, you will be able to do the interact with this using a client application. There are various client applications like Go Ethereum, Python Ethereum, Ruby Ethereum. Plenty of Ethereum clients are available that make our life easy for developing codes, writing applications, and then making a blockchain network. So then you know that there are some token smart contracts like Ojha is one of the token smart contract that this is used for only money transfer, token transfer. And they remember that smart contracts run on top of the decentralized network. So you have this off-chain app. This off-chain app to a API calls these smart contracts, token smart contracts, and applications. So application smart contract will require some kind of transaction. This transaction can be performed using those token smart contracts, and then the decentralized networks resources will be performing the operation. That is how it happens. Okay, so I hope this is clear to you all. I'll come at the end. So somebody is asking, can you visit the last slide again? What are some popular D apps into? Well, in each area, there are some popular D apps. In each area, there are some popular D apps. Let me quickly finish this kind of D apps we have. So according to Ethereum white paper, D apps can be classified into three types. One are those D apps that are purely for digital cash transaction, right? Like famous example is Bitcoin blockchain. I would like to take you to this website of Bitcoin Explorer. I hope you can see this Bitcoin Explorer. So here it is showing that this is the amount of one Bitcoin is costing this much, this 1 Ether. And this is showing me latest blocks. I'm enhancing the size. Latest block, like height of the block is this much. This is the size of the chain, right? Then we have this is the miner. Now you do not know who is this miner, right? And this is the size of this block. These many transactions. The block mine is ago and almost and 25 to 6. Right side, you see those. Let me take you to a block. So this is block number 717099. So that is the length of the blockchain, Bitcoin blockchain. This is the header, which is a cryptographic value. Now this is containing some zeros. How many zeros should be there in front of this is what is one of the proof of works. Like you have to select how many zeros should be there based on a difficulty level. Difficulty level here is this. So this is a completely probabilistic, like one randomly selects a value and then tries to increment one by one, finding out how many zeros should be added. Then the timestamp is something which is very important. This is the miner. You cannot know who is this miner. It can be one of you. Number of transactions here are there, 496. Right? So nonce is a number used only once. It's a transaction volume, you can see 23,729 Bitcoin. In this block reward is very high. As you can see, 6.25 BTC is the reward given to the miner. And the fee reward, gas fee. A computation that you put transactions up to this. That is how you can find out. It's a purely dependent on digital cash transaction, right? Then there are second types of blockchains where currency is involved, but there is some kind of other external inputs, transactions plus some other business, like blockchain in agriculture could be there. Or there are a third type of, which are purely for business logic, nothing to do with like voting, governance. Voting, yesterday Samir told you, a use case of disaster relief. Here I will go to this blockchain network, IBM. On this IBM website, you will find this blockchain, where you can, it's a video, you can see how blockchain can be effectively used for disaster relief. I'm going back to the slide because we don't have enough time to discuss. So these are three types of blockchains, right? And then there are three categories also which you will find in the literature. One is those DApps which have their own blockchain. The other types of DApps we have which use the blockchain of other like DApps. Like you can say that they use type 1 DApp function, right? So their main function is something else, main business is something else, but for functioning they use other blockchains, right? They use DApps which in their turn use their own blockchain. And the third type are which use the protocols of type 2 DApps, but they have their own. So this is a hybrid kind of blockchain, right? Various types of Abhishek, we will come to mining in a later lecture. I don't think I should continue with this decentralized autonomous organization. I will continue this in the next class. And I would like to take questions from you. And I've answered several questions, but let me check if there are some questions which are, I'm sorry if there are some questions which are not answered, please don't mind because this is a long list. And don't ask for, please share PPT, please share video lectures. We are sharing that, okay? Let's just go to your Canvas account. If you have not got the Canvas invitation, it might be because you wrongly entered your email. In several accounts, we have found out it has bounced back because we don't know your correct email. If in your registration process you have wrongly entered the email, then you may not be getting it. Please contact your coordinator in that case. Why are rewards provided for mining? So you are using a lot of computation. You are like putting your energy and resources. Why you should not be rewarded? Some person sends 1 BTC and another person gives another 2 BTC, and lastly that person uses it all. BTCs, all hash are the same. They are not hash. See, the moment a transaction of a Bitcoin takes place, a unique hash of that transaction, unique identifier, forget about hash, unique identifier of that transaction happens. Think of a bank, your passbook, from which source you have received money. Suppose you have got 200 rupees in your bank, forget, not 200, suppose 20,000 rupees in your bank. These 20,000 rupees, how you have received, your banker can trace back from all the sources. He can tell you that these 20,000 rupees are taken, you have received from X, Y, Z resources. It is like this only. They will not, and so those resources will have a unique reference number. When I ask you to register and you registered in the platform of some academy, what did you do? You wrote a payment reference number, and that is a unique reference number. It is just like that, right? So, what was the meaning of blocks in the blockchain technology? Einstein maths don't matter. I'm going one by one. There are some interesting questions. Einstein maths, somebody is asking. Okay, I go back. Voice is breaking. I'm so sorry for some glitches in the network. We have been experiencing this. Please explain Ethereum virtual machine. So Ethereum virtual machine is using resources of all the nodes in the network, all the computing resources. Can both blockchain based and off blockchain based storage exist for one blockchain solution? Yes, Neeraj, both blockchain and off blockchain. Off the chain storage are for large, like photo. I wanted to show you a pet shop example of Solidity, but I could not do. Maybe I can get time. Please send your YouTube link because some students waiting for link. I do not know whether I placed it on YouTube or not. Is reshaping network in blockchain network effective? It creates performance issue. What is reshaping? There's no reshaping required here. Cryptographic challenge mechanism, you need not understand. You only understand that there's some challenge mechanism that is thrown to you. So some cryptographic hash is presented, and right now I'm telling you, because for a beginner it will be too complex an idea. That is where. So there is a challenge, like show that you have got this, right? Show that you have got this. So matching something and telling that, okay, I've got this. It's something like that. All right. So how intense incentives provide?